Hello and welcome to Red in April Off Grid. This video is part of our Looking Back series where we bring you video footage of some of the projects that we did earlier on the property. This is video from a year and a half to 6 months ago.
I did the best I could cleaning up these older videos, but they are still a bit rough and the sound is up and down.
But bear with us, we think the projects are interesting and we hope you'll enjoy. We plan to bring these videos out midweek just kind of as a bonus video until we're caught up to the present. This video is really two videos combined into one, and it covers the installation of a man door in the shipping container as well as ventilation, and we also get started on the components in the solar room. Getting set up to put the man door in the side of the shipping container. So what I'm going to do is I'm just going to cut a hole in the side of the shipping container, the size of the door, and then I'm going to use that piece of metal that I cut out as the door. So I'm going to frame it, put it back in. So that's the plan anyway, and I'm about to get started. There were some kind of bulges or damage to the side of the shipping container. Something on the inside of the shipping container hit the outside of the walls and kind of made them bulge out. It's just kind of bulging out there. Anyway, I had to find a good spot to put the door in where it was relatively straight and flat. And so here's the spot. I put it in right here. I carefully marked the location out with a soapstone and then started cutting the door out with my oxyacetylene cutting torch. It's not making a really smooth cut here. It's kind of struggling a little bit as it goes through the paint, but it's working okay, and now I'm ready to knock the door out. It's the end of the day and I'm about to start putting up my tools, but I wanted to show you my progress so far. So I've got the hole cut in the door for the door, and I've got the outer frame fabricated, cut to size, and ready to weld tomorrow morning. And so I want to show you what I use for that. So I use these tall purlins here. These are 8-inch wide purlins. Each door will require 10 feet as I'm cutting it in half lengthwise and using the 4-inch pieces to create the frame for the door. Something I learned along the way here is I used the cutting torch, cut it lengthwise to rip it, and it kind of distorted the metal. I think if I had to do it again, I would use a abrasive disc on my handsaw, which is what I use to do all the finer work. It really actually worked pretty well. I was able to fabricate some of these pieces. It was pretty precision. The blade lasted for quite a while, so I would definitely recommend the 7-inch cutting disc for the handsaw. I was able to cut in some notches so it fits the contour of the metal at the top for this top part of the frame. So anyway, tomorrow morning I'll fire up the welder, get these welded in, and then get started on the door. Well, those frame pieces fit pretty good, and here I am welding those on. This kind of completes the frame, and I'm just about ready to move on to manufacturing the door. Since I'm using that piece that I cut out, I needed to build kind of a frame around that sheet of metal that came out. And so I'm using a angle iron, attaching an angle iron kind of piece of trim all around the outer edge of the door, and then I'm doing some 3-inch straps across the door that will align with the hinges that I will be applying. The hinges that I'm using here are weldable hinges. They're kind of expensive, heavy-duty hinges, one of the most expensive parts of the door for me, actually. But they're made to be welded, and they're really nice and heavy-duty. And so I just clamped the door in place, got it all lined up, tack welded it, made sure it was worked and it was in the right location, and then finished up the weld. These worked really nice, and the door opens and swings real smoothly. It's about midday on Friday and the door is finally complete. Got my steps in place. Metal is painted and protected. It doesn't have a traditional door handle. I just made a place where I could put a lock through right here. And then it just swings open. Also wanted to show you the pins that I put in place. So I put in some pins, top and bottom, that can only be undone from the inside. So there's a place right here where I can put a pin through. And then once that pin is through, top and bottom, there's no way to open it from the outside. It can only be opened from the inside. So if we're going to be gone for a while and want to make it really secure, I'll put the pins through. I'm getting ready to frame in a little room in the back of one of the connexes here for my solar control parts. And in order to do that, I had to weld on some brackets in order to attach the framing to. So there's one bracket on the middle, and then I welded another one on top. Did that on both sides. And then I'll just drill some holes through those, and that'll give me something to attach my wood framing to. So I finished our solar control room for now. It's in the shipping container barn that we have. And so just a little disclaimer, I wouldn't build something this way if it was in a house. We were trying to achieve something that had good thermal insulation that will keep the interior temperature of the solar control room lower in the summer and warmer in the winter. We've gone with the foam insulation, reflective side facing out to reflect the heat back into the rest of the shipping container. On the outside, something important we've done is we've painted the outside with white elastomeric paint. Just painting the outside surfaces, the container will lower the temperatures dramatically. And so that's our first kind of layer of temperature control. The second layer is the insulation. Just a really quick, easy door. Made it out of 2x2s, some scrap pieces of OSB, and a leftover piece of insulation. So super cheap and easy. Didn't even put a doorknob on it. I just got some wire here holding it closed. So here's the inside of the room. It's kind of dark and a little bit hard to see right now. But as you can see, we just basically coated the walls and ceiling with this insulation. We'll see how this works. It's just glued on to the walls with liquid nails, and it seems to be well secured. Also on this wall, I have a piece of OSB along this whole wall to attach my solar components to. So not quite done, but we've got a good start on it. This is what we have so far. We'll see how this works and give you an update.
In this video, Red is installing vents in our shipping containers, adding more insulation and sheetrock in the solar room, and starting to mount some of the solar components. We arrived late the night before, spent the day arranging and unloading our stuff, and made a trip to town to purchase the materials for the vents and solar room. We only had 2 days to work on the containers, but got quite a bit done. He's getting ready to cut a hole right here to put the vent in, and then once he gets the vents in, we're going to put another layer of foam insulation in, and then put drywall on top of that.
This is the next step in our strategy to passively cool our shipping containers, and we're going to do that by adding good ventilation. A lot of people will just put the ventilation up high on the wall and call that good, but what we're going to do is put one up on the wall and then put one down on the floor in hopes of getting some air movement and circulation through the trailer. So what I'm hoping is that cooler air underneath the shipping container will come up through the floor vent and then migrate across the shipping container and up towards the vent that's up by the ceiling. And I think we'll get a good airflow and a good circulation, bringing the cooler air in from the bottom and bringing it through the container. Since hot air rises, it should happen naturally and passively, and should equalize at something close to an outdoor temperature is what we're hoping for. Maybe a little closer to what the shade temperature might be, but we'll see how well it works. This is the solar room, and I've done the same thing in here. So this room will be isolated from the rest of the shipping container, so it's going to have its own vent system, passive vent system, which includes the vent up by the ceiling and the vent in the floor. The next step in here is to go ahead and add some more foam insulation. We want it to be really well insulated from the outside to keep it as cool as possible. So we're going to add one more foam board, and then I'm going to put on a piece of drywall. I'll coat the walls in drywall except the wall that I'm going to be attaching my components to, and that's going to be a fire barrier because this stuff is foam board is really flammable.
So everything has double layer foam now, and we're just setting the drywall right on top of the foam sides.
And then I'm also going to put some hardy board, which is it's a board that's not flammable. I'm going to put that on my component wall, and I'll attach the components to the hardy board. And I'm also going to put some on the floor directly below my components. So just fire protection, the best way I know how to do it. Okay, I have the major components mounted now, and I've just been careful to watch for clearance all the way around. For ventilation purposes, for the units to keep cool, they need to have the proper clearance around the units, which has been difficult to achieve, but I think it's going to work. On this unit here is the inverter. It's going to be what gets the hottest. In order to help with the ventilation, I went ahead and put blocks behind it and mounted it to blocks. And that allows the air to come behind it a little bit and kind of have air circulation all the way around. And the wiring is going to come in from the top and make a circuit, come down into the controllers. Then it'll go down through the BMS into the battery, up into the inverter, out of this side of the inverter and into the box, and then down and out. So it'll make a nice route without overlapping. So those were kind of the design considerations that I've taken into account as I've laid this out. Okay, so here's the box I made for the batteries. I wanted a box to put them in so that when I'm working on these components up here, if I drop a wrench or something down on the batteries, I won't, short everything out and cause sparks and fire and all that kind of good stuff. So it'll be in this box. It's mostly fireproof. Underneath it is insulated. So the part that's on the ground has insulation between the floor and the batteries. Then it has a top I can put on to protect from dropping tools and stuff onto the batteries. It also has a cutout in the back where the wiring will come down.
As was recommended by a friend in the area, we put the containers up fairly high to discourage critters from trying to live under them. When they are set too low or the bottom is skirted, the mice and snakes are hidden. The higher gap discourages pests from moving in.
The septic is inspected, but that's just they inspect the connections on the tank itself. And then the setbacks from property line is the only other